Hey guys, Wes here. In this video, we're going to do a deep dive into everything that you need to know to use Git as a professional software developer. So I recently released a video about using GitHub Actions to conduct some continuous integration workflows, and I had someone reach out and ask me if I would make a video in general about how to use Git for version control. And if you're here watching this video, then you probably already realized that Git is used almost ubiquitously across the industry for version control. There are other version control systems out there like SVN and Mercurial, but Git has really risen to the top as the most widely used version control system in the industry. So imagine trying to work on a software project with 3 or 4 other people without version control. So you'd essentially have to communicate and collaborate about write permissions to the files so that you wouldn't be overwriting each other's changes. It would be a nightmare to try to manage conflicts, and essentially the entire project would be extremely difficult to manage just because of the fact that multiple people are working on the same files in a file system. And so what Git really provides us with is a really effective way to collaboratively work on source code together. I should say it's also a really fantastic tool for working on source code independently, because it allows us to create branches where we might have an idea that we'd like to work on separate from sort of our main, our master branch, if you will. And we'll get into the details about branching in this video, but just know that Git provides us with some really fantastic tooling to work collaboratively or independently on software and manage and track its changes over time. And so with that, let's dive into the terminal and we'll look at exactly how you would use Git as a professional software developer. Okay, so first let's just get set up, and I'll demonstrate how to set up Git if you're running on Windows first, and then we'll look at making sure we can get it set up on macOS. So if you're on Windows, I would head over to gitforwindows.org and then just download the installer for Git for Windows. This is going to include Git as well as Git Bash, which will provide Bash emulation, allowing us to run Unix-style commands in a Windows operating system here. So go ahead and download Git for Windows if you're on Windows, and then run the installer. So once Git for Windows is installed, you should be able to open it up here, and you'll see that you have a terminal emulator. And just to double check that Git's installed, we can run git -- version. And this will show us that in this case, I'm running git 2.26.2.windows.1. And if this works, then you are actually ready to get started using Git. Now let's take a look very quickly at how you can get set up if you're on macOS. If you're on macOS, the easiest way to install Git is just to use brew, and you can brew install Git by running brew install Git in your terminal. Once this is set up, you should also be able to run git -- version, and you'll see the Git version out to your terminal here as well. Okay, so the first thing that we're going to do is actually update our Git config to set our email and our name. And so to do this, we can run the command git config -- global user.email, and then here you would type in your email, and then we would run the same command here for our username. And once you've done this, you now have essentially set your identity globally when you're using Git in this particular environment. So every time we make changes to a code base, our changes will actually be associated with our username and email. And so this, for one thing, is going to allow us to see who makes changes to our project over time. So for instance, if we have a single file that many different developers make changes to over time, we'll actually be able to use Git to see exactly who made what changes on what lines at what time to that particular file as part of our Git repository. Okay, so once we've set up our config here, let's actually go about creating our first local Git repository. And so for this, I'm going to make a project directory here. We'll just call it my project. And now I'm going to move into that directory. And if we take a look at what's in here, we can see it's just an empty directory. But now we're going to run our first real git command here besides the config, and that is git init. And this is going to initialize a new Git repository in this particular directory. So if we take a look at everything in this directory now, we see this .git subdirectory that's been created. And this is really important. Every Git repository has a .git subdirectory, and this will be where Git is actually storing all the information it needs to track our project over time. So before we actually get into the specifics, I think it would be useful to talk about a high-level sort of cadence that we're going to follow here, and then you'll find that this cadence just sort of flows naturally as you code and make changes to your project. So we're going to be running the following commands sort of over and over again as we make changes to our project. We're going to be running the command git status. This is going to give us the current status of our project, what Git has noticed that has changed, for instance. And then we're going to be running the command git add. I won't run this just yet because we have nothing to add yet. And we're going to pass that -A in this case for the first several examples. This is going to add all of the changes that we've made in our Git repository to what's called the staging area. And this just is sort of an area that we put our changes before we're ready to commit them. And commit is the next Git command that we'll run. But just think of this git add as saying, okay, I'm going to now collect all the changes that I've made, and then I'm going to run git commit to actually change the history of my project by this commit action. So add will add them to the staging area, and then we're going to run git commit, which will actually make an actual commit with all of those changes. And then we're going to, when we run commit, we'll use this -m to put in our commit message here, which might be like change some file. And this commit message will be what's associated with the changes that we've made and basically captured in this snapshot with the commit command. So let's actually put this into practice. So we have an empty directory except for .git, the subdirectory, and let's just touch a new file here. We're going to touch a file just called program.py and make a new Python file. So we can see we have that file in our subdirectory. And now let's see what happens if we run the command git status that we just talked about. Okay, now we see we're still in branch master, but we have this untracked program.py file that Git is now aware of. So it's telling us that nothing's been added to commit, but this untracked program.py file is present. And you can see it even tells us to use git add to track it. So we're going to run git add -a. That's going to add all of our changes, which in this case is just that one file. And now if we run git status again, we don't need to run git status, but if we do, we can see that we've added this to our staging area. And it shows us a way to unstage if necessary. We typically won't be doing this very often, but now we can see we have this new file, program.py, that we are ready to commit. And so let's run our first commit. It's going to be git commit -m, and I'm just going to say add program.py. Now, just so you're aware, there are typically conventions surrounding how you should format your commit messages depending on what team you're on. And it's totally conventional. It's just a string that we put in here to describe some change that's been made. A really typical convention here is to use sort of an imperative mood here rather than sort of a past tense, some changes that were made, because this commit is capturing the changes in a sort of imperative sense. This commit essentially adds this file to the history of the project. And so again, this is just convention, and the most important thing is really to establish a convention if you're working with other people, and having some typical sort of canonical format to your commit messages will really help in the long run in sort of reading through them easily, and just something to be aware of. Okay, so we're going to run this command now, and we can see that Git tells us that one file has been changed, and we get this create mode program.py out. So now if we run git status, we can see now Git saying, okay, there's nothing to commit, the working tree is clean. We've actually captured that snapshot of our repository at that point in time, and we are good to basically continue making changes if we'd like. So now I'm going to open up this project in a text editor and we'll edit that file. So here we are, and it's a Python file. I'm just going to make a small change here to print hello. Okay, so we made the change to our file, and now let's see what happens back at the terminal if we run git status. Well, Git is now aware that we've made a change to program.py. And one of the ways we can have Git sort of show us what changed is by running the command git diff. And so here we'll see that the program.py file has changed, and the plus sign shows us what's been added. So we can see hello. And if we hit Q here, this is going to sort of exit out of that diff mode. Now, if we run git status, we can see, again, that's what's changed. We'll run git add -a to add those changes, and then we'll make a new commit message here saying add print statement. Okay, so now what if we wanted to see the various commits that we've made in our project? Well, one of the easiest ways to do this from the terminal is just to simply run git log. And here we're going to see a list of the various commits that we've made. So we can see they're in order here. This long sort of string that you see here of numbers and letters is the commit hash. And so all that you really need to understand about the commit hash at this point is that this is a unique identifier that Git's using for this particular commit that has been made. You can also see that the author will be your name and your email at whatever your email is when you ran the git config command. And again, we see our second commit and our first commit here. So let's just type Q to get out of this. And let's make one more change. We'll head back over here. We're just going to print another change has been made. And now if we run git status, we can see we had our change. If we run git diff, we can see the change that's actually been made here. And in this case, the editor or Git is actually saying it looks like that the hello was removed and then re-added. Sometimes this happens just depending on new lines and other things, but that's okay. We can see that at least print hello is here, as well as the new print message that we have. So I'll type Q, and then we'll run git add -a and git commit -m, add new print statement, clear, and if we want to see all of our commits again, we can just run git log. And again, Q will get us out of this view, and if we just want to view one or two at a time, we can run git log, and let's run like -2, and we can see the last two changes, for instance. Okay, so that is really sort of the bare bones basic approach to tracking changes with Git. And so far we've looked at the commands git config to set up some config. We've looked at the commands git add, git status, git commit, -m, and on add we were using -a, and git log. So already we've looked at a handful of Git commits that are really just a part of typical day-to-day work with Git as a version control system. And of course we looked at git init as well, which initializes a new local Git repository in whatever directory we like. Okay, next let's look at setting up a remote. So we've made our new project here, and we'd like to actually push this up to a remote repository like GitHub or Bitbucket or GitLab or Azure. There are lots of them. GitHub is super popular, so let's just use that and get set up. So you'll see your profile page here. I'll let you explore GitHub. There are a ton of features here that are beyond just sort of hosting remote Git repositories, but for our purposes what we're going to do is just create a new repository. So we'll head over here, select new repository, and I'm going to use another account for this, the productive dev account in this case, and we're going to call this repository my project, and here you can provide a description. I'm going to make this a private repository for now, but just know that a public repository means that, as you can see here, anyone in the world can visit GitHub and see your code. Everyone will also be able to see every commit that you've made, and so this would be typically used for like open source projects. or projects that you generally just might want to share as part of your work or your portfolio. Private projects, of course, you can only see, and you can also control who else would see explicitly. So we're going to ignore the other options for right now and just create this repository. So now GitHub is going to show you the quick setup steps, and really from here it's just a matter of following these particular steps. Do note that if you're going to use SSH, I will show you how to set that up briefly. Otherwise, you can use HTTPS here as well. For now, let's use HTTPS, and you can see exactly what we need to do. If we want to just create a new repository, notice that what we're doing here is very similar to what we've already looked at together. Echo is just going to take the output here, my project, and push this into a readme.markdown file. So this will just be a markdown file with a header, my project. Git init we've already looked at, that would create the repository. Git add would add that readme file to the repository. Then we see our git commit-m, and then a new command here, two new commands which are important. And you'll see that that's actually the stage that we're at for pushing an existing repository from the command line. So these commands are git remote add origin, and then the URL to our project, and git push -u origin master. So what these commands are doing is saying, I want to associate my local Git repository with the remote repository at this particular URL. And then git push -u is going to say, in this case, -u is setting the upstream origin, in other words, the remote here, to master branch, which we're currently on. We'll talk about branching here shortly, but we're going to push all of those changes up here to GitHub. So I'm going to use SSH, and I'm going to run this first command. And just so you're aware, I'm going to update my config again here. I'll skip this part in the video just to be my correct email and name again. Okay, so now we're going to git remote add origin, that particular origin of your project. And now we're going to git push -u origin master. So the output we get here is that branch master is now set up to track remote branch master from origin. So let's go back to our GitHub repo, and if we refresh the page here, we'll see now that our program.py has been pushed up to GitHub. So we now have a remote repository, and our local repository is actually tracking that. If we want to see what remotes we have available, we can run git remote -v, and we can see these two origins here, essentially fetch and push from the same place. Okay, if you want to set up SSH to work with GitHub, what I would recommend doing, the easiest way to really go about that, is to head over to Settings, and then head over to SSH and GPG keys, and you'll see the list of SSH keys associated with your account here. At first, you won't have any SSH keys, and so what I would do is simply follow GitHub's instructions here for connecting to GitHub with SSH. If you don't want to use SSH, you can use HTTPS, and it will simply ask for your username and password when you make a push to your Git repository. Okay, so let's work through our cadence one more time here just to get a sense for how it's working. We'll head back to our project here. I'm going to open up the editor, and we're going to delete the line 2 here. We're going to just go ahead and save that, and now we'll run git status. We can see that there's been a change. We can run git diff to see the change. We can queue to get out of that. We can git add a, and then we can git commit -m. Remove print statement, and now we can git push. Since we've already associated our local repository with the remote, it's going to push to that branch master. And if we take a look back at GitHub and refresh the page here, we can see that that change, that commit, has now been applied and reflected in our remote repository. So we can do some pretty cool stuff here. We can see the history of this file and the various commits that were made. We can click on a commit and see the diff. You can also see the unified diff or split diff, just depends on how you want to kind of view your changes. Okay, so all is well here. Now let's look at another very powerful command, which is the clone command. So one of the really nice things about Git is that it is a distributed version control system. Everyone who has access to the project has the full history, but the question now is, how do other people get access to this code base and make changes to it? Well, what they would typically do is they would come over to the repository and you'd want to clone the project. So you'll see you can clone with SSH or clone with HTTPS. If you haven't set up SSH keys, then just use HTTPS. But what we're going to do is just copy the URL, and then let's say we're on a different machine. So for this, I'm just going to go to a different directory here. So now I'm in a different directory, and if I want to pull down this project, let's say I'm on a different machine or I'm a different developer, I'm going to run the command git clone and then the URL. In this case, I'm using SSH, but again, use HTTPS if you haven't set up your SSH keys yet. So what this is going to do is you can think of cloning as basically going out to that particular remote repository that is accessible at this URL, and then it's going to pull all of that down into a directory of the same name. So now if we cd into my project and take a look at what's in here, we can now see that we've actually just pulled that project down from GitHub again to a local repository on our machine. And this is in a different directory just to demonstrate that if you were on a different machine or if you were a different developer, this would be how you would go about getting that particular project. Okay, so what I'm going to do here is open up another terminal window here, and I'm going to go into the original My Project. And so this part will just be for simple demonstration. You don't have to follow along directly here. It would be more useful just to kind of take a look at what's happening. So on the top pane, let's say I'm developer 1. I'm working in my directory here, which is in users West projects, my project. And on the bottom pane here, I'm developer 2, and I'm working in a different directory, users West, my project. So 2 different directories just to simulate 2 different developers working on the same project. So what I'm going to do is, again, if you're just to watch and follow along here, I'm going to, as developer 2, make a change. So we'll come in here, we've got the print hello. So developer 2 was here. So I have a local repository that developer 2 is working on. If they run git status, they've modified program.py. Of course, developer 1 is unaware of any changes being made whatsoever because he or she hasn't made any changes to their code, even though they're working on the same code base. They're both working with local repositories. So developer 2 now makes a change, which we've looked at, and now they're going to add their change, and then they're going to say updates print statement or something, and then they're going to push their changes. So they've pushed to master branch. We come take a look at the remote. Take a look here. Looks like we got developer 2's changes here. Hello world. Developer 2 was here. So now what if developer 1, how do they know changes have been made? Well, they don't necessarily know changes have been made. They are just editing away here. They still have the old version while developer 2 has the new version. So in order for developer 1 to get the changes that have been pushed up by developer 2, this developer will have to run git pull. And so what git pull is going to do is it's going to go look at the remote, and it's going to pull those changes down into the local file system. So we now have program.py. We can see that there were some changes made here. 1 file changed, 1 insertion, 1 deletion. And now if we're to edit this file, we have developer 2's changes. Okay, so now you may be asking, what if both developers make changes unbeknownst to the other? So let's say developer 1 comes down here, and this person makes a change. So it makes an update statement. They add their changes. and they push them. And meanwhile, developer 1 makes their own changes. So now they're going to add, and then they're going to commit. And before they push, they want to pull changes from master just to be sure they have the latest changes. So they're going to try to run a git pull. And you're going to see that they now have what's called a merge conflict. And so Git is saying, hey, I can see a change on remote, and you've made a change here locally. I need you to confirm exactly what you want to happen here. So in this case, there would probably need to be communication between these two developers saying, hey, I made changes to this particular print statement. I see you made changes too. When I try to pull your changes in, Git's telling me we have a merge conflict, so how do we want to resolve? So if we were to edit this file, we can see that Git's going to give us this interesting syntax here. So it's going to start with these sort of left arrow brackets saying head, and then it's going to say the different update print isn't here. Then it's separated by these equal sign separator, and then some other update that was made at some other commit hash. So how do we resolve this conflict? Well, this is just the file that we have, and it's just showing us that there is a merge conflict. So these changes are actually these changes that Git has made have been written directly to this file locally. So Git, by looking at this, sees that there's a merge conflict, and we now need to resolve it. And if we're going to resolve this manually, we just need to pick a particular change that we want to keep and remove the other one from this file. So let's remove the other one and just leave the commit that leave the change rather that we'd like to keep. So we're going to save and quit this. I'm going to run git add and then git commit, and we're just going to run update print statement and then git push. We come back to GitHub and refresh. We get our correct update. And then if we were developer 2, we can now run git pull. Okay, so now you may be thinking, well, won't I run into conflicts all the time? If we're all working on the same file, won't this happen often? And the answer is, well, that depends. If you are working in this way where everyone's working on the same branch, that's not really a recommended practice here, because you'll find that developers will tend to be making changes in the same place, and you'll have to resolve these conflicts through some type of communication. And so typically what we would be doing is, when we're doing feature development, we'll be working on branches other than master. And so the way to think about this is, we're going to branch off of master. We're going to make some changes to the branch that we're working on, the new feature branch. And then when we're ready, we can make as many commits as we want on that branch, but when we're ready to apply all of those commits at once back to master branch, we will merge that branch into master. So let's take a look at how we can do that. So they're going to run the command git checkout -b, and they're just going to call this one my feature. So you can see Git's telling us that we've now switched to a new branch called my feature. And my terminal is set up to display what Git branch we're on, and we can see that I'm now on my feature. Developer 2 is still on master branch, no problem, but developer 1 is working on their feature branch. And so let's make a new feature as developer 1. So I'm going to edit the program again. You can use VS Code here if you like. Here's the new feature. Git status. They're going to git add -a git commit, add new feature, and then they're going to run git push -u origin my feature rather than origin master this time. So now we're setting the upstream to my feature branch. So what's just happened here is that we have created a new branch called my feature, and we've made some changes locally. Then we've pushed to an new upstream branch called my feature, which is tracking our local my feature branch. We can view all of our branches if we just run git branch. We can see that we have master and my feature branch. Developer 2 doesn't even know that the new feature branch exists quite yet. For instance, if they were to run git branch, they just see master branch and they can continue working on that if they like. But if we want them to know about, or if they rather want to know about that other branch, they can just run the command git fetch. And it's going to take a look and it's going to say, hey, in your remote repository, I see that there's been a new branch created. And now if developer 2 wants to start working on that new feature branch, they can just run git checkout my feature. And now they're switched to that branch. They can go back to master by running git checkout master. And by working on separate branches like this, each developer is able to continue making changes and commits against their own branch without actually interfering with work that the other is working on in their particular branch. Now, typically in most workflows, you won't be working on master branch directly, but master branch will always sort of be like the working code that's recognized as being complete up to some given point in history. And typically developers create feature branches, work off of them, and then merge back into master or merge back into some other sort of trunk branch that is capturing all of the changes, and then is typically the main trunk that we would create new branches off of. Okay, so let's head back to GitHub. We'll go back to my project, and GitHub will say, hey, I see that there are two branches, master branch and my feature branch. Now let's say that we made some changes to my feature branch. We can browse the repository here. You can see here's the new feature. That's all good. If we want to look at this on master branch, we can just switch branches directly and see that the snapshot on master is of course different. So now we have this new feature, and let's say that we're ready to merge this feature branch into master branch. So how do we go about doing this? Well, there are a couple of different ways to do this. We can do this from GitHub directly, and this process is called creating a pull request. So if you head over to pull requests, we can see that you have recently pushed to my feature. We can compare and pull request, and then we can leave a comment here that says, like, adds new print statement or something. Basically just capture a description of those changes. Then we can create that pull request. There's a lot more features in GitHub here, for instance, assigning reviewers, creating and assigning labels and projects and milestones, and you can assign yourself to the pull request. And then really the key point here, though, is that we can then merge this pull request. So what's going to happen when we merge this pull request? Well, it's going to take our feature branch and actually merge those changes directly into master. So when we do this, master branch will then have all of the changes that we made in my feature branch. And there are more nuanced options here. For instance, we can squash all the commits that we made into one single commit with a squash. We can rebase, which is a little bit out of the scope of this particular intro, but just know that this merge is effectively going to take all of the changes that we made in my feature branch and merge them into the history of master, and master will then reflect those changes. So you could do this, and then you could delete your feature branch because you're no longer working with it, and then check out a new branch off of master to make maybe my feature 2, for instance. The nice thing about creating a PR in this way is that we can also see the files changed, and we can review those changes. We can comment, approve, or request changes. This is all sort of specific to GitHub's user interface. You'll find similar features in all of the other remote hosts. So on GitLab, for instance, they call these merge requests or MRs, and on GitHub they call them PRs or pull requests. We weren't working through this process, and say we're just working independently and we want to have separate feature branches that we work on just to keep our changes out of the sort of main line, if you will, we can use the git merge command directly from the terminal. So what we would do is we would check out master branch. So this switches our branches over to master, and then we would run the command git merge my feature. Now be careful when you do this. This is going to immediately merge that my feature branch into master locally. So we're going to do this. We can see that everything's been merged, and now we're going to run git push, and this will actually push those changes that we merged in to master branch. So now our pull request is noting that it's already been merged. GitHub is smart enough to note that. We can delete the branch here as well. We can also delete the branch from the terminal. But if we head over to the code and we take a look, we're on master branch, program.py, we now see our new feature. Now if we're developer 2 and we want to get those changes, once again, it's as simple as running git pull when we're on master branch, and we get those new changes locally as well. Okay, if we want to delete the branch locally, we can run git branch -d, my feature. You can see it's going to delete that branch. If we wanted to make a new branch, again, we can git checkout -b, some new feature, and continue this process. So that's pretty much it. I hope you guys enjoyed this high-level intro to Git, and in particular working with Git on GitHub. If you have any questions or comments or concerns, please leave them in the comments below. I'll do my best to get to them. It's been a while since I really thought about explaining Git for those who have not yet become familiar with it, and so I'm sure you guys will have a ton of questions. Please let me know if there's anything I can clear up here, and I'll be sure to answer those as soon as possible. As always, thanks for watching, and I'll catch you next time. All right, that's it. I hope you guys found this video valuable. If you did, I would really appreciate it if you liked the video and subscribe to the channel if you're interested in more deep dives into various topics in software engineering, machine learning, and DevOps. As always, thanks for watching, and I'll see you next time.